Very nice. Thank you so much. All right, important properties of algebra. So again, we're looking at the foundations of algebra. You have to know this stuff before we can move into the more challenging stuff, because, and actually this is really the last of the foundational stuff. Next tomorrow probably we'll actually be moving into equations and solving equations, which is awesome. But in order to understand equations, you have to understand these properties. They're really important. Luke, go ahead. Yes, totally. So there are tons of properties of algebra, and I'm not going to go over all of them. There is a property that says x equals x, right? Like 2 equals 2. There is a property called the reflexive property. Forget it. I'm not going to go into those ridiculous ones, right? In my opinion, ridiculous. Right? They're so obvious. But I'm going to talk about some key ones, some really important ones that you will use all the time. All right? And here we go. The first one is called the commutative property. All right. What is the root word of commutative? Yes, Lucas. Commute. What does commute mean? Rosemary.
Like a commute is where you go to one place, usually for work or school.
Right. Your parents commute to work. They don't. Most of them don't work at home. Some of them do. So some of them don't commute, right? But most parents do commute to work. They leave their house. They get in their car. They drive to work. That's called commuting to work, right? You often hear people say, oh, I'm commuting to Los Alamos. My dad commutes to Los Alamos every day, right? It's usually, it means movement, right? So this is what the property actually looks like. X plus y is equal to y plus x. That is the commutative property of addition, okay? And it's flipped, right? Notice x moved, changed places with y. But it's totally legal. Let's try it with numbers. 2 plus 5 is equal to 5 plus 2. Is that true?
Yeah.
Absolutely true. Absolutely true. So this is actually called the commutative property of addition. Right? That's what this is. And this. There is also a commutative property of multiplication. And that would be very similar. Would be x times y is equal to y times x. Again, x and y commuted, right? They moved. They changed places. Does it make sense? Mm-hmm. Right? You guys all see that?
Yeah.
An example of that. 2 times 7 is equal to 7 times 2. That is correct, right? 14 equals 14. Yes? So it's totally fine to have commutative property of addition and of multiplication. It is not okay to have commutative property of division and subtraction.
Yeah.
For example, I cannot do this. So I'm going to put no here. Right? I cannot do x minus y is equal to y minus x. I cannot do that. What I could do, though, is I could turn it into an addition problem. I could say x plus a negative y is equal to negative y plus x. Or, yes, yeah, right, yeah, that's right. Right? I just, as long as that negative stays with the y when I move it, then I actually use the property of addition. Does that make sense? You see what I'm doing?
Yeah.
Anybody else, anybody confused? But if I don't do this, if I don't turn it into an addition thing, then this cannot work for commutative property. Nor could a division. If I said x divided by y is equal to y divided by x, is that true?
No.
5, no, not 5. Let's use a number that works. 8 divided by 2, does that equal 2 divided by 8?
No.
No, totally not, right? I can't do that.
No.
I can't do that. So it doesn't, commutative property does not work for addition or, does not work for subtraction or division. It only works for addition and multiplication. But you will use it all the time. When you're solving equations, you'll see it all the time. And as we move into those, I'll try to highlight those or identify those in the next few days. Number 2. The next one is called the associative property. Okay, the associative property. An associative property, I'm going to just erase this, is that okay? So that it's not in my way. Associative property, this is what it actually says. Let's see here. X, Y, Z. X plus Y plus Z. All right, and with my Z, I'm going to put a line through the middle of it so that it looks like a Z and not a 2, is equal to X plus Y plus Z. Now, did the letters commute?
Yes.
I have X,
Oh,
Y,
they
Z.
didn't.
I have X, Y, Z. They didn't commute at all. What did move, though? The parentheses. So when I see parentheses, I think of, like, these guys have an association together, right? They're associating. They're socializing. You know what I'm saying? So to me, that helps me remember associative property. Oh, X, Y, and Z are standing right here. Boom, boom, boom. Each with their little cup of tea, right? X and Y are talking to each other. Poor Z. I mean, he's often, nobody's talking to him. He's just drinking his tea. Wishing he had the kind of tea they did. Wishing they would care about him. All of a sudden, Y turns this way. And suddenly, Y is talking to Z. And poor X, right? But it doesn't matter. But that's the associative property. X and Y are socializing here. Y and Z are socializing here. Does that make sense? You see it? Yes.
Why is like the popular kid who never gets left out? Like,
Yeah.
It's not fair. It's not fair. Why never gets left out?
I
The
know.
other two just
Now,
why does Y
But then Z and X can talk
So-
to each other.
so how can you tell the difference? Because once everybody gets it when they see it, but then once I give you the homework, you're going to look at stuff and you're going to say, oh wait, which one is which, right? How can you tell the difference between commutative and associative? Gardner.
So the commutative property is the numbers are switching places,
Right.
and the associative property is the parentheses.
Okay. Did anybody have, well, that's totally true. Anybody have anything they want to add to it? Luke?
The associative property is just kind of moving numbers over, but still keeping the numbers the same and the sign, or the signs might differ,
Mhm.
but they're the same thing, and the
Right.
commutative is just switch.
Yeah. Now, again, okay, more. Yeah, Rosemary.
Like the associative property, the numbers are still in the same order in this case. The
Correct.
parentheses is just the
Okay.
same. Whereas in the commutative property, it's flipping over. It's
Right.
like looking into a mirror.
Right. Excellent. Jan.
So in the commutative property, the numbers flip over,
Mhm.
and maybe in the associative property, the only the parentheses flip over and the numbers flip.
Right, exactly. Beautiful, beautiful. And like commutative property, let me just think for a second, would this work? So it works best with addition and multiplication. It won't work so well with subtraction. Because think about it, if I had, let's see, if I had X, well, let's do multiplication first. If I had X times Y times Z, that's equal to X times Y times Z. It's totally, right? It's the same thing. Same thing. And if we plugged in numbers, it would always work, right? But if I suddenly did subtraction, it would not work so well. Because if I had a negative here, right? If if I had this, watch this. If I had x minus y plus z, right? And I have this, watch this. If I did, does that equal this? X minus y plus z.
No.
No, it doesn't. Because this negative sign here did not affect the z. But here, the negative sign affects the y and the z. And we'll talk about that in a second. That's called the distributive property. That's the next property we're going to talk about. So again, with associative property, it only really works for addition and multiplication, okay? Now the third one, main property, is distributive property. And you will be using this all the time. I feel like I'm going downhill here, aren't I? Okay, distributive property. All right, so this is what the rule actually states. A times B plus C is equal to AB plus AC. Now, if you think about it, parenthesis always means what? Yeah.
Well, it means multiply
Right.
variables touching it all.
Uh-huh.
It means do it first.
Right.
Simplify what's in
Yes, okay. And now, since they're both unknowns, right, B and C, I can't really add them together right now, right? I don't know what they are, so I can't combine them. So, but I can do what Jan was saying, I can do the multiply. Go ahead, Jan, what would I?
So
Explain
you
it.
do, since you can't simplify B plus C because you don't know what they are,
Right.
you just multiply them both by A.
Yes,
So you would do A times B, which would be AB,
right,
and then A times C, which would be AC.
exactly. So you're basically going to draw little arcs, and I suggest that you get in the habit of doing this for a while, because if you don't, you're likely to multiply A times B, and you're going to forget to multiply A times C. But if you do the arcs, you're less likely to do that. So the arc means A times B, oh, right, AB. And then plus A times C, AC. You guys see that? So we're going to practice a few of these. Can I erase this so I can...
Yeah.
Okay. You guys have everything? I don't write too well when I'm so low unless I bend down. All right, how about, okay, so we're still on distributive property. Let's practice a few of these. Distributive property. So let's say I gave you 2 parentheses x minus 7. So can I combine inside the parentheses x minus 7?
No.
No, because I don't know what x is, right? If I knew what x was, I could, but I don't. So I've got to use my arcs in my distributive property. So 2 times x is what?
2x.
2x. And then 2 times, this is what I do, is I think of that as a negative 7. I don't think of it as minus 7, I think of it as a negative 7. The negative belongs to the 7. So now I'm saying 2 times negative 7.
Negative 14.
So positive times negative is negative, right? Negative, and then 2 times 7 is 14, right? All right, let's try another one. How about 3 parentheses 2x plus 12. Okay, so you guys sound like a recording. Okay, 3 times 2x is 6x, right?
Yeah.
I'm multiplying the 3 times that number in front of the x. What's that number called again?
The coefficient.
Coefficient, right? Coefficient. So 3 times the coefficient, 3 times 2 is 6. So that's 6x plus 3 times 12 is 36. Right? Fist of 5 so far? You guys get it? All right, what if... Good. All right, what if I give you this one? Negative 4, parenthesis, 2x minus 6. All right, what would I get? Somebody different. Another volunteer. Tess, you had your hand up. Oops. Sort of. but not to raise your, but what would I do here? So I'm going to use the distributive property, right? So I'm going to multiply the negative 4 times the 2x. What would that give me? Positive or negative?
Negative.
Negative, right? Negative times a positive is a negative. So you see how we're using now those rules? Right? You're going to use those rules all the time. All the time. Right? So just, we'll review those in just a second, just to make sure. Okay, negative 4 times positive 2x is negative 8x. Negative 4 times negative 6 is positive. Negative times negative is a positive. 4 times 6 is 24. Plus 24. Good. Awesome. Yes?
How would you solve this? Are they solvable?
It's not solvable because right now all I'm giving you are expressions. I'm putting an equal sign because this equals that expression, but there's no solution. Does that make sense? Because this is exactly the same thing as this. And if I had turned it into equation and said that equals 10, then I could solve it. But if I'm doing this, if all I give you is this, it's not an equation. There's no way to solve it. All you can do is simplify it. And you put an equal sign to say it's simplified as that. But since it didn't start with an equals 10, you can't solve it. Does that make sense? Right? I mean, if I tried to solve this, I mean, if I gave you that, what would happen? I'd get 0 equals 0. Because I'd have 2x, I'd multiply this out and I'd have 2x minus 14 equals 2x minus 14. I'd subtract 2x from both sides, I'd have no x's. 14, or negative 14 equals negative 14. I'd add 14 to both sides, I'd have 0 equals 0. See what I mean? But if you don't understand that, don't worry. We're going to understand that like in the next few days. But what if I gave you this, though? What if I gave you this? What if I gave you that? If I gave you that. Brisa, what would I do? What would you do? Jaden?
Wouldn't that negative turn into a positive?
Would you just multiply everything by negative?
When you're multiplying, yeah, go for it.
So you put a 1, because you can always put a 1 next to it.
So whenever there's not a number, there actually is a number. There is a 1. If there's no number there, if it says just negative parenthesis, it's negative 1 times everything in there.
And then you do distributive property with negative.
And the cool thing about this, with negative 1, whenever you're multiplying an expression by negative 1, everything changes its sign. If it's a positive number in here, it becomes negative. If it's a negative number, it becomes positive. So that would be equal to negative x squared, negative 2x plus 7. All I did is I made this positive negative. I made that positive negative, and I made that negative positive. Right? You see what I mean? That's all I do. I don't even bother with the 1, putting in the 1 in there. I just think of it as the negative, say negative 3x plus 4. I just rewrite it. Oh, negative, I've got to make all of this reverse, right? I mean, remember, negative means the opposite of, right? The opposite of this. The opposite of negative 3x is positive 3x. The opposite of positive 4 is negative 4, right? You see what I'm saying? See what I'm saying? So, all right. So that's distributive property. Now, let's see. Can I erase?
Oh no.
Never mind.
Which I can erase this side.
Yeah.
This side's okay. All right, that's good enough for me. All right, so now we're done with distributive property. We need to do the product. Let's see, what is it called? Product of zero property. And this is a very easy property. I love this property because it's so easy.
0.
X times 0 equals
0.
0. Anything times 0 equals 0. That's it, right? All right, so
What about 0?
what if I gave you 5 times 0? What would that equal? 0. What if I gave you negative 2x cubed plus 4x squared times 0? 0, right?
Yeah.
Doesn't matter how bizarre and weird something is. If it's being multiplied times 0, it's nothing. It's absolutely nothing. So that's a pretty, yes, exactly. Lazy person's best friend. Exactly.
0 eats everything. The black hole.
All right. Now, that's for multiply. But for divide, dividing by 0 is a big no-no. That's why I'm wearing my shirt. It says friends don't let friends divide by 0.
Why?
Right? They don't let friends divide by 0. It's really, really important we understand this. So, let's see here. What did I call it? Division with 0. That's all. That's easy. Division with 0. Let's look at this for a second. This is so important to understand. So important. If I said, well, instead of that, let's do this. If I said 0 divided by 5 is 0, right? That's okay. When 0 is upstairs, it's totally fine. But it's going to be 0, right? If you have an upstairs value of 0, your answer is going to be 0. If your downstairs is 0, though, if you have 0 under the line, the answer is undefined, right? So if I had 5 divided by 0, the answer is undefined. Meaning, undefined means you can't do it. It's impossible. It's absolutely impossible. What we know, let's think about what we know about division. All right, let's try this. How about 8 divided by 2 is equal to what?
4.
Everybody understands. Everybody agrees with this?
Yep.
Right. So if 8 divided by 2 equals 4, then I can go backwards, right? I can say 4 times 2 is 8. Works great, right?
Yeah.
Okay. Let's try this. Let's try 0. Let's try this one. 0 divided by 5 is 0. Let's try it. Okay, if 0 divided by 5 is 0, then I can go backwards. I can say 0 times 5 is 0. Works great. Works great. Now let's try this one. Let's say instead of undefined, we said, oh, well, 5 divided by 0 is 0, right? Let's try that. All right, 5 divided by 0 is 0. Now go backwards. 0 times 0 is 5.
No.
Yeah.
Right? That doesn't work, right? So then other people say, well, wait a minute. 0 goes into 5 an infinite number of times, right? A huge number, right? Never ending. So we'll just say infinity, right? Infinity is not really a number, but it's a concept, right? That goes on forever and ever. But let's try it. Let's try it. 5 divided by 0 is infinity, right? Because you're dividing a huge number by a very tiny number that's so tiny it doesn't exist, right? Right? And so it makes sense. It'd be infinity. But let's try it backwards. And infinity times 0 does not equal 5. Right? So the key is friends never let friends divide by 0. So you guys are all friends, and we have to make a pact today that we will never let any of us divide by 0. Okay? Raise your right hand. I do solemnly swear
I do solemnly swear
that I will never let my friends
that I will never let my friends
divide by 0.
divide by 0.
Period.
Period.
All right, good. All right, you got that settled.
I
All right.
my right for this.
So, if that were the case, what if I gave you this? 8x minus 14.
0.
0. Oh my gosh. How about I gave you 4x to the 10th, z to the negative 12th, times y to the negative 465th, to the 0. I mean, times 0.
0.
Right, it's 0, right?
But the
Easy
last
peasy.
one, the one on the left is undefined.
Oh, wait.
No, not that one, the other one.
The other one, God.
Oh, yeah. Right.
That one's undefined.
They're all
That's not
undefined.
0. You let me divide by 0, guys. That's not okay.
Yes, it is.
Undefined.
It's
It's
perfect.
undefined. Oh my gosh, I can't believe I did that. On the video. Oops. Oh, well. Okay.
And it's on camera.
Oh, yes.
Yes, man. Watch his mistakes. Every last one of them.
We're gonna have to make a new video.
Okay, you gotta do a new video, right? Okay, no. Okay. I gotta find my cap. So
It is somewhere here.
All right. So that's basically it. Let me just look at the homework and be sure I haven't forgotten anything.
His mistakes. I'm just gonna replay that over.
I have to write it on my hand because I will always forget to watch it. So I need to write it on my hand to watch it.
All right. So I think that should do it. I think what I'm going to do now is I'm going to give you the homework, and you're going to have some time to finish it. Actually, before we do that, let's just review a couple things. But I think I'm going to turn this off. Is that okay?
Yep.
Because